Hello everyone, I'm Nitin Reddy from EC. My topic is polar codes for soft decode. Introduction. Polar codes have been selected for protecting the 5G new radio control channels as a benefit of their superior block error ratio performance at short block lengths. Therefore, both hard output and soft output polar decoders have been investigated in the literature. The soft input HO polar decoders typically rely on the original successive cancellation decoder proposed in our sphere decoder of whereas SISO may be produced by the belief propagation algorithm. Polar code encoding uses an SNR independent method where the reliability of each subchannel is computed offline and the ordered sequence stored for a maximum core length. The nested property of polar codes allows this sequence to be used for any code, rate, and all core lengths smaller than the maximum core length. There are, the SC decoder is capable of approaching the binary input discrete memoryless channel capacity for infinite block lengths where the channel is sufficiently polarized but exhibits poor BLAR performance of realistic finite block lengths due to the associated error propagation. Considering a list of candidate bit sequences and operating on the basic of logarithmic likelihood ratios, the logarithmic successive cancellation list polar decoder developed from the SAL decoder of improves the error correction performance of the SA decoder in the case of practical block lengths. The software and hardware implementations of the log CL decoder have been investigated in which have a low memory requirement and a low decoding latency. However, the log SAL decoder is not a CISO scheme and hence fails to exploit illiterate iterative LLR updates gleaned from the detector of turbo receiver. We conceive a soft list polar decoder which is achieved by intrinsically amalgamate the log SCL and left to right PP decoding without requiring inner iterations. This approach exploits the excellent error correction capability of log SCL decoder as well as the soft output of BP decoder. Additionally, an LLR flip technique is applied in the proposed soft list polar decoder for matching the BLAR performance of the log CL decoder. The soft list decoder achieves a 50% lower decoding latency and 26% complexity reduction. When decoding a half-rate polar code having a block length of 1024 compared to the state of the art SISO scan polar decoder, we demonstrate that the soft list polar decoder allows iterative extrinsic information exchange within a turbo receiver which has a better BLAR in a multiple input, multiple output, single communicating over fading channels. And there are different types of polar coding. One is physical layer and DCN, physical layer introduction, DCN digital transmission, DCN analog transmission, and DCN transmission media, and DCN wireless transmission, and DCN multiplexing. Last one is DCN network switching. There are few polar decoding algorithms. Algorithm 1 soft list polar decoding algorithm. The input is LLRS LM. The output is that coded a posteriori LLRs RM and the decoded bits do not perform log SCL decoding according to diff and store LJ in each layer. J belongs to 0, to M. re-encode the most promising candidate sequence not perform backward BP decoding by employing and with the left all LLRS LJ, picking those of best candidate sequence in the log SCL decoding. For I equal to 0, 1 comma n minus 1 do. If sign of Ri comma m equal to 2 ui comma m minus 1, then rim equal to minus ri comma m. Else ri comma m equal to ri comma m. And if second algorithm is ME soft list polar decode algorithm. The input is the detected LLR LM. The output is the coded posted LLRS RM and the decoded bits unit. Perform log SCL decoding according to a re-encode the most promising candidate sequence unit. Memory efficient soft list polar decoder. The MA soft list polar decoder also starts with log SCL decoding. However, instead of storing all S candidate bit sequences and generated LLRS, the decoder only stores the S candidate bit sequences and the LLRS required to perform the log SCL decoding. More specifically, when decoding the rightmost layer, only n by 2 LLRS output by the F function are stored so that they can be later input into the G function. Due to the serial nature of the log SCL decoder, the same memory can be reused for the calculation of the G function at this layer. Later for decoding the subsequent bits. Similarly, the decoding in the Jth layer only has to store n by 2 LLRs to perform the F or G function, as in the log SCL decoder. Performance of soft list polar decoding. The performance of both soft list polar decoder in terms of their BLER latency, complexity, and memory requirement in a 2 into 2 multiple input, multiple output system communicating over flat uncorrelated trailing fading channels. BLER performance. BLER performance of the proposed soft list polar decoder for a 2 into 2 MIMO VBLAR system communicating over fast uncorrelated trailing fading channels, where I equal to 8 outer iterations and gray coded QPSK are employed. Note that since the BP, scan and the proposed soft list polar decoders rely on the CISO multiple, the right hand output after the backward LLR propagation is performed of extrinsic LLRs pertaining to the encoded bits, which can be interleaved and directly input to the memo detector for use in the next iteration. However, the conventional log SCL polar decoder does not have soft output capability, hence only a single outer iteration is employed for a polar coded memo system employing a log SCL polar decoder. And the polar codes used in the polar codes to encode the downlink control information DCI over the physical downlink control channel PDCCH and the payload in the physical broadcast channel PBCH. And the advantage of polar codes are they have modest encoding or decoding complexity of n into log n. As a result, they can use it for many applications, including 5G wireless transmitter or receiver. They are explicit in construction. They are easy to implement due to simple coding and decoding algorithms. Conclusion. In the case of decoding, a off-rate polar code having a block length of 1024, the proposed ME soft list polar decoder achieves a 1.5 dB BLR performance gain, 50% latency improvement, and 26% complexity reduction. Compared to the state of the art scan polar decoder used in a polar coded multiple input, multiple output system. For further reducing the memory requirement, we proposed a MIS soft list polar decoder, which requires only 16% of our original soft list polar decoder's memory, and it maintains the same BLAR performance. Thank you.